All right, everybody, this is Module 5, Lesson 2. We're going to be talking about the area of right triangles. So the easiest way I can show you this to help it stick is to simply finish the triangle off as a rectangle. Now, we know area of rectangles is length times width. So when you look at this figure that see how I drew that line? You see I've created two of these triangles. One is flipped over. And that creates a rectangle. This right angle right here, if I were to make this a right angle and then create the parallel sides, creates a perfect rectangle. And that's what length times width creates. So what two sides would be the length and the width here? It would be the base, which is 15, and it would be the height, which is 8. So we know that the area of a right triangle, it's an RT, involves base times height. But now we recognize that this is not part of our area. This was drawn on extra. The area is half of that rectangle. It's just this part, right? The black outlined triangle. So we don't need this 17 feet. We don't need the diagonal line. We only need the base and the height, kind of like parallelograms in lesson 1. We only need base times height. But now, because we don't have 4 sides, we only have 3, we're going to take that base times height, and then we're going to divide it by 2. And that will give us the area of a right triangle. So we would set this particular problem up like this. We would do base 15 times our height, which is 8, and then we would divide it by 2. 15 times 8 is going to be 40 plus 80, which is 120. And we're going to divide that by 2, which is going to be 60. So the area of this triangle is 60, and the label's the same as any area. We're doing feet times feet, right? The dividing by 2, we're not dividing by 2 feet, we're just dividing it in half, because when we did 15 times 8, we created the rectangle. All right, 8 times 15 would give us the area of this rectangle. But then we're going to just divide by 2 because of the diagonal line, creating 60 feet squared. So on this exercise, you see they didn't even give you the diagonal side because it's not necessary. But again, you can picture, if I were to just draw a vertical line here at 90 degrees from the base, I know it's not perfect, I create 2 identical or congruent triangles. So all I need is the base times the height, and then I'm going to divide it by 2 because of this diagonal line. So I would set up the problem 11.4 times 17.7, and I'm going to divide that by 2. So you can use a calculator here because we're not assessing if you can multiply 2 numbers with decimals. This is, do you know the formula on how to find area of triangles? We assume that you can multiply these like this and divide by 2 like this. So feel free to use a calculator unless you would like extra practice on multiplying decimals and then dividing decimals. So when you multiply 11.4, the base, times 17.7, the height, you get 201 7/8. Then over here, you do divided by 2, and you end up with 100.89. So the area for this triangle, right, is 189 hundredths centimeters squared. Okay, so you try question 3 and 4 here. Pause the video, see if you can find the area of each triangle. All right, so let's look at question 3. Okay, so the base is 8 inches. The height is 6 inches because here's our right angle. And the diagonal is, I always see that as like the opposite side. If I were to try and think of this as a rectangle, the opposite side of the base. And the height goes up and then connects that diagonal to the base. So I'm doing 8 inches as the base, 6 inches as the height. So I'm going to multiply 8 times 6, get 48. And then remember, I'm dividing it by 2 because what's happening is if this was a right angle and this connected to here, I'm creating 2 identical triangles. But I don't need this section. So I'm dividing by 2 to get rid of that section and leave me just the triangle that I'm originally looking for. So 48 divided by 2 is 24, and therefore the area is 24 inches squared. Let's look at number 4. All right, so we established the base is 8 2/3 meters. The height is 5 3/5 meters. So we're going to be multiplying those, which would give us this rectangle. But since we need to get rid of this section, we're going to divide by 2. So when you multiply these, you do end up wanting to do this on paper because 2/3 as a decimal is going to be 0.66666666667 continuously. It's an irrational number. So it's easiest to just do it like this, then make them improper so you can multiply straight across. So 8 2/3 is 26/3, and 5 3/5 is 28/5. So now I multiply 26 times 28. I did that off to the side. Feel free to use a calculator. That's 728, and 3 times 5 is 15. Now this is just 728 divided by 15 to make it a mixed number, and I end up with 48 with 8/15 left over. And so my area is 48 8/15 meters squared. How'd you do? Okay, so there's your example. Remember, the area of a right triangle, okay, is found with, I'll write it right here, the area of a right triangle, RT is what I'm using for that, is base times height divided by 2. So try these out and check back with me for the answers. Don't forget to pause. All right, so for number 1, my base is what's going to come 90 degrees from my height, so it's actually the top here, and again, kind of opposite of the diagonal in my mind. So the base is 31.2, height is 9.1. I'm going to multiply those together and get 283.92. Feel free to look at that if you need to, but you could have used a calculator. And then I'm going to take that product and divide it by 2 so that I just get the leftover triangle, because remember, multiplying them gave me a rectangle. And I end up with 141 96 centimeters squared as the area. For number 2, we have the base of 5 kilometers, and we have a height of 3 3/4 kilometers. I did it as decimal form because it's easier when I have a whole number and a decimal in my mind. So I multiply base times height, then I get 18 3/4, and then I divide 18 3/4 by 2, and I get 9 3/8, which is 0.375 in decimal form. And so my area is 9 and 0.375, or 9 375 thousandths, or 9 3/8 kilometers squared. For number 3, we have a base of 2.4 inches. This is the base, this is the height. Actually, according to my typical thing, this could be the base, this could be the height. But since this is on the bottom, I'm calling this the base. It really doesn't matter because you're just multiplying the two sides that are attached to the right angle. So what you call base and height isn't important as long as it's the correct sides attached to the right angle, that their corner makes the right angle. When you multiply those, you get 7 68 When you divide 7 68 by 2, you get 3 84 And so your area would be 3 84 inches squared. Number 4, pretty simple one. I did 60 as my base and 11 as my height, but really doesn't matter the order as long as it's the two sides with the right angle. Just 660, because 6 times 11 is 66 with a 0. And then dividing that by 2 would just be 330. So 330 millimeters squared is the area for number 4. And number 5, interesting math here, but it was kind of fun. So I did 10 13 1/3 as the base and the height because that's what's touching the right angle. So when you have a whole number times a whole mixed number, you can do the whole number times whole number and then that whole number times that fraction. So that'd be 130 plus 10/3, because 10 times 1 over 3, because the denominator of 10 is 1, which is 3 1/3. So that gives you 133 1/3. And again, a calculator on this one won't work very well because to do 1/3 in a calculator is an irrational number of endless 3's after the decimal. So then I just made this an improper fraction because 3 times 133 is 399 plus 1 is 400. So that's 400 thirds. And dividing by 2 would be dividing by 2 over 1. So it's the same as multiplying by a half, right? Dividing by 2 and multiplying by a half are the same thing. So 400
sixths is what you end up with. So now I just do 400 divided by 6, and I recognize that it's 66 and 2/3, which again ends with an irrational number of an endless number of 0.666666667. And that 7 only shows up because it has to stop somewhere, but it really doesn't in real life. Your just calculator only has so much space. So doing this on paper works best. Either way, 66 and 2/3 feet squared would be your area for this triangle. So number 6 is, just logic. Don't try to use formulas and mathematical equations here. Just use logic. These are two congruent rugs. So they have the exact same area. And each of them is cut in half, just in different ways. So that means A and B are exactly the same, and C or D are exactly the same. But that also means that A has to be the same as C and D, and they all have to be the exact same because it's the same total cut in half, just in different ways. For number 7, I'm going to zoom in right over here and make the question disappear. And then I'll talk about how to give dimensions of a right triangle and a parallelogram with the same area. So this question really becomes quite simple when you simply write out the formulas, right? Parallelogram is base times height divided by 2 is for the area of a right triangle. So just pick a number that both of those equal. So I'm just going to choose 10. Make it nice and easy. And now I just plug in numbers that work. Over here, base times height being 10 would mean that my base and my height would have to be a 5 and a 2, right? So over here, I put base and height as something divided by 2 to equal 10. So I would need that top section to equal 20. So now over here, my base times height, right, would have to be two numbers that equal 20. So that could be 10 and 2, that could be 4 and 5, right? So maybe I make my base 4, maybe I make my height 5, and that gives me 20, right? And then 20 divided by 2 is 10. So those are two different shapes with the same area based on their formulas and plugging numbers in that make it true to equal the same answer. So this question is many steps, but you can do this. Pause it if you need to. So the original formula is base times height divided by 2 equals 9/16. It tells us that here in the question. So all we have to do is multiply both sides by 2, and we get base times height equals 18/16. So now we can plug in h, 3/4 as our height, times b equals that 18/16. So now to balance the equation, we divide by 3/4, and that leaves us b, but that means we divide 18/16 by 3/4. When you do that, you end up with, I made an equivalent fraction. 3/4 is 12/16. Now I have equivalent denominators, so it's just 18 divided by 12, which ends up being 1 1/2. So the base would be 1 1/2, the height would be 3/4, and when you multiply that and divide by 2, you get 9/16. And just to prove it, I plugged it in. 3/2 is 1 1/2 times 3/4, which is 9/8, and dividing by 2 is the same as multiplying by 1/2, and 9 times 1 is 9, 8 times 2 is 16ths, so you get 9/16. Well, there you go. Let me know if you have any questions on Schoology or leave a comment or a like. Grade 6, Module 5, Lesson 2. Have a good day.